Hey kiddos, welcome back. This is CA number 1 review part 2. This will be numbers 11 through 21. Okay, number 11. Trisha is building the framework for an entryway window for a house under construction. The window is in the shape of a right triangle. A right triangle just has a right angle. You'll learn a lot more about these when you get to geometry. Okay. The height of the window is represented by the expression 6x minus 7. So I'm going to put this where the height is, 6x minus 7. To allow for the maximum amount of light in the entryway, the area of the window is represented by the expression 24x minus 28. That's the area. What is the base? So the base is down here. So what we need to know for this is we need to understand the formula for area of a triangle. Area of a triangle's formula is base times height divided by 2. The problem is we don't know the base. Now what we do know is we know the area, right? The area is this 24x minus 28. So I'm going to put that on the left side in place of the area because I know what it needs to equal. On the right side, I don't know what b represents. Right? I don't know what b equals, but I know it's being multiplied times the height, which is 6x minus 7. And then this is all divided by 2. So what I need to do here is I kind of need to simplify this equation and see if I can't figure out what b equals, okay? If I could somehow figure out how to make this side look like this, then I would know what my b equals. So remember when we distributed, when we had a number in front of parentheses, we multiplied it inside. Well, if you have a number under a parentheses, like this 2, you can divide it inside also through distributing. Okay? Let me see if this is the best way to show you. We can do it this way. So I did this a different way in the answer key, so you might want to look at that way if this way doesn't make sense to you. Okay, so if I was to rewrite this equation, I would still have the 24x minus 28 on the left equals b times 6x divided by 2 is 3x. Negative 7 divided by 2 is negative 3.5. We'll use a decimal this time, that's fine. So what I need to figure out is what this is, right? And this base is being multiplied by this height, which I've divided by 2, right? So if I could think, okay, what numbers would I multiply that by so I could get this 24 and this 28 over here, then I would be good. So what number times 3 gives me 24? That's 8, right? So what if b was 8? Let's try. 8 times 3x minus 3.5. Let's see if that gives us this 24x minus 28. So 8 times 3x equals 24x, and 8 times negative 3.5 is negative 28. And you can use your calculator. So that works. Now that's not my answer. My answer is this 8, though, because that represents the base. So that goes here. So when I go back up here, if I did 8 times that height, I distributed that 8 in, and then I divided that all by 2, I would get this area that I was looking for. So the answer here is 8. This problem is a lot like the other rectangle problem where we subtracted the perimeters. This one is once an expression that can be used to represent the sum of the perimeters. So we're basically adding these two perimeters together, right? So let's take a look at what we've got. We've got rectangle ABCD again. And it says at the beginning that ABCD has a length represented by 5x minus 1. So that goes here. And a width represented by 3x plus 7. So that's on the side. Okay. I'm just drawing my pictures right now. Then we have the other rectangle that's JKLM, and it has a length represented by 2x minus 5, and a width represented by the expression 4x plus 11. Okay, so let's go ahead and find these perimeters, and then we will add them together. So remember we said perimeter for a rectangle. Remember, you can just add 5x minus 1 plus 3x plus 7 plus another 5x minus 1 plus another 3x minus or plus 7. Or you can count 2 of the lengths plus 2 of the widths. I wouldn't say one is better or worse than the other. But I like this way because then you get to practice distributing. But if you don't like distributing, you may just want to add all 4 together. Remember, we're just combining like terms. We're not solving any sort of equation here. Okay, so we're going to distribute the 2 first here and here. So 2 times 5x is 10x. 2 times negative 1 is negative 2. Plus 2 times 3x is 6x. 2 times 7 is positive 14. Okay, so now we're going to combine our like terms. I've got a 10x and a 6x. Those combine to make 16x. I also have a minus 2 and a positive 14. Those will combine to make a positive 12. So this is the perimeter of ABCD. So I'm going to add to that whatever I get for the perimeter of this other rectangle. So let's find its perimeter. 2 times the length plus 2 times the width. 2 times the length of 2x minus 5 plus 2 times the width of 4x plus 11. We'll distribute those 2's inside those parentheses. 2 times 2x is 4x. 2 times negative 5 is negative 10. Plus 2 times 4x is 8x. Plus 2 times 11 is 22. Now we'll combine our like terms. I've got 4x plus 8x. That's going to combine to make 12x. And then I also have a negative 10 or minus 10 plus 22. And that's going to combine to make positive 12. So this is my perimeter of the second rectangle. And since we're adding, we don't really have to worry about parentheses around the second perimeter because they're all being added together. Now remember, if we were subtracting one of the perimeters from the other, then the second one would definitely need to be in parentheses and I would need to distribute that negative 1. Let's go ahead and combine these like terms. 16x plus 12x. Those are going to combine to make, what is that, 28x. And then we also have the positive 12 and the other positive 12. Those combine to make positive 24. So the sum of both of the perimeters is 28x plus 24, and that would be h. Here's another problem that wants an equivalent expression. Remember, look at your expression. There are no equal signs. You're not solving. You're not moving things from one side to the other. You are strictly getting rid of parentheses by distributing and then combining like terms. So for this one, we've got a lot of decimals. You may want to have a calculator handy. In the first set of parentheses, we're going to be distributing this 2.5. In the second set of parentheses, we're going to be distributing this negative 3.6. And in the last set of parentheses, we're just going to be distributing this negative 1. Okay, so we've got a lot to do. Here we go. All right, so 2.5 times 4.2x is 10.5x. 2.5 times 7.4y is positive 18.5y. Whoops. Okay, now we're on to the second set of parentheses. Negative 3.6 times 8x is negative 28.8x. And then negative 3.6 negative 3.6 times negative 4.5y is positive 16.2y. Lastly, we got to distribute that negative 1. Remember, that just changes the sign. So that 2.4x is going to become minus 2.4x. And that 6y is just going to become minus 6y. All right, I've gotten rid of all my parentheses. Now we're ready to combine like terms. We've got 10.5x. We've got negative 28.8x. and we've got negative 2.4x. So you literally just want to put those numbers in your calculator. 10.5 minus 28.8 minus 2.4, and you will get negative 20.7x. Okay. Now we're going to, and I'll get a different color, we're going to combine our y's. We've got a positive 18.5y, positive 16.2y, and negative 6y. So we're going to put those three guys together. And when you put those together, you get positive 28.7y. This is your simplified expression. I can't combine the x term and the y term because the variables don't match. So I'm going to leave those separate. So your answer is B. Number 14, the table below shows the number of Japanese yen that could be exchanged for US dollars on the day Charlotte came home from her trip to Japan. Which statement could describe the relationship between the number of Japanese yen and the number of US dollars on this particular day? And does the relationship represent a function? Let's first decide whether it's a function or not. Remember, to decide if it's a function, I'm going to look at my input column, which usually in a table like this is the first column. Notice none of these values repeat, so I can say with confidence that yes, it is a function. So I'm going to eliminate h and f because they say no, it is not a function. Let's look at the difference of these two. G says the number of yen, it says the number of yen is 120 times the number of US dollars. So it's saying if I take the US dollars times 120, I'll get the number of yen. Let's see if that works. So 5 times 120 is 600. 15 times 120 is 1800. And 30 times 120 is 3,600. So that actually works. J is saying that the number of yen is 595 more than the number of US dollars. That would mean to add 595 and you'd get the number of yen. If I add 595 to 5, yeah, I do get 600, but that's the only one it works with. If I add 595 to 15, I'm only going to get 610. 1800 is way, way off, so this is not going to work for that one. So the answer here that I want to choose is G. For this one, they want to know which set of points would not define a function. Remember, if any of your x values repeat, it is not a function. So we're looking for x values that repeat. So you can just pay attention to the x values. These x values are all different, so it is a function, so it's not my answer. If I look at the inputs, or the x values of choice B, I see, yeah, they're all different too. That means that is a function, which means that's not my answer. C, let's look at those input values. Uh-oh, I see this 0 appeared more than once. And uh-oh, I see this 3 input also appeared more than once. This is not a function, so that's probably my answer, but let's just verify that D also is a function. -6, -5, -4, -3, -2, those are all different, so that's a function, so that's not my answer. What you could also do here, they have provided a graph. You could graph this. Now on the star, if you remember from last year, there is a function where you can actually plot points and draw lines. I don't know if you saw that last year, but definitely on your algebra star this year, it is going to be online. However, you are provided graph paper, so you could also work this out on your actual paper. You just won't get this particular graph on a piece of paper. Another way to determine which one's not a function is you could graph the points. You would have to graph the points for 4 different answer choices. So you would be using the same graph, and that could get confusing. But you could also just use the answer, or just graph the answer that you think is correct, just to verify using the vertical line test. If I graphed the points in C, I would have -1, 0. That's a point right here. I would have 0, 1. That's right here. Whoops. It's hard for me to do points on here. Hold on just a second. Okay. And then 0, -1 is right here. Well, we're right here. And then 3, 2 is here. And 3, -2 is here. So if I was to try to use the vertical line test for this relation, it would fail right here because it crosses it twice. And it would also fail right here because it crosses twice. So this definitely is not a function, so C is correct. 16 says, which graph below represents a non-functional? Non-functional meaning it's not a function. So since we have graphs, we want to just do the vertical line test. If I do a vertical line for F, it crosses once, crosses once, crosses once. Okay, so pretty much it passed those vertical lines. So this one is a function, so that's not my answer. G crosses it once, crosses it once, crosses it once. So G also is a function, which means it's not my answer. H crosses it once, one time. Okay, so H is also a function, so it's not my answer. It's probably J. Let's test. Yes, it crosses it 1, 2 times. Remember, if it crosses it more than 1 time, it is not a function. So J is the one that is not a function or non-functional. 17, which table represents M as a function of T? You'll also see it as Y as a function of X. Don't get too caught up on this. If it just says function, you're looking for a function. The letters before and after are basically telling you your output and your input variables. So it would tell you the output variable first and your input variable second. So it's basically saying your output variable in this case is M, which is in the second column, which is what we're usually used to, right? But to determine if it's a function, we're going to look at the input column. And remember, for it to be a function, we're looking for our input values to not repeat. On A, every single one of these repeats. That's not a function. On B, nothing repeats. -9 and 9 are different numbers, so B is probably our answer. On C, the -4s repeat and the 7s repeat. On D, the -6s repeat. So B is definitely a function. That's our answer. Don't be scared of these bubble grid ones. Sometimes students get really scared because they don't have those answer choices there to kind of, verify if they're getting the right answer or not. Just be confident, go with your gut. A lot of times these are actually a little bit easier than you'd think. They're not going to make them super hard. Some other things that you won't see in a bubble grid. You will not see fractions, okay? You will not see variables. So you're really just looking for some kind of positive or negative whole number or decimal number. Those are the only types of things you can bubble. All right, 18. The table below represents the data collected in experiment to determine the representative function comparing the angle of incline of a ramp and the distance a model car travels after it leaves the ramp. So basically we got X's on the left, outputs, or Y's on the right. All right, cool. Evaluate the function for f of 30. So since that 30 is in my parentheses, that is the input. It wants the output. Okay, so we just have to look at our table where 30 is our input, that's right here, and the corresponding output is 42. So that's going to be our answer. So we would just write in 42, we would bubble in the bubbles, and we'd be done. See how easy that was. All right, given f of x equals 2x plus 1, so we have this function, 2x plus 1. Find the range value, that's the output, if the domain value or input is 1.75. So it's giving us this input value. Now normally I would say go to your calculator, graph this, press Control T, look for this input of 1.75 and give me the output right next to it. However, the table on your calculator only has positives and negatives, or the integers, the whole numbers. It's not going to have any decimals. So if you have a decimal input, you have to enter it by hand. So we're gonna figure out when I input 1.75 for this function, what does it equal? So we're going to rewrite that rule, but we're going to take out the x and put 1.75 in parentheses. 2 times 1.75 plus 1. And this part, you can type into the calculate part of your calculator, and it will figure that out for you. Or you can just do it by hand as well, especially if it's easier numbers. But if you're not sure, don't hesitate to type it into your calculator. So if I type this into my calculator, it's going to give me 4.5. If I want to kind of do it by hand, 2 times 1.75, this part, equals 3.5. And then plus the 1, that's going to equal 4.5. So my output is 4.5 when my input was 1.75. So you would put it like this. You would have to actually put the decimal in its own box. See, it has its own circle. And then you would bubble in those parts. Remember, if it's positive, you don't have to put the plus here. If you want to, you can. But if you don't, it will default to a positive. All right, 20. The graph below represents a function. Yes, I can see it. The vertical line test would work. What is the value of f of 4? So since 4 is in parentheses, that's my input. That's my domain. That's my x value. Okay? It wants the value of f of 4, so it wants the output or the range or the y value. So it wants the y value for this x value of 4. So we're going to look at the x-axis. We're going to go to where 4 is, and it happens to be right at our graph. So the coordinates of that point are 4, 0. So when my input is 4, my output is 0. 0 is what it wants. So G is my answer. All right, last one. Which mapping best represents the function f of x equals 2x squared plus 5x plus 3 when the domain is -1, 0, and 3? Domain, those are your x's, right? So what you're going to do, the easiest way to figure this out is go to your calculator from the home screen, press, 1 for document, 1 for new document. When it asks you if you want to save, press no, 2 for add graphs, and then you're literally going to type this in. Remember the little squared button is right next to the 4. Once it's graphed, press enter. Then you're going to pull up your table. You're going to press Control T. And then it's going to give you your table. Remember, the first column is really skinny. Those are your X's. The second column is your outputs. That's your range. So you're just going to look for each of these 3 numbers in the X column. And then whatever number is right next to it, that's the output. Okay? So if you look at -1 in your table, you should get an output of 0. For 0 as an input, you should get an output of 3. And for 3 as an input, you should get an output of 36. The answer is B. So make sure that whatever the input is over here, the arrow goes from it to its actual output over here. It needs to match up. And that's it, kiddos. If you have any other questions, feel free to message me, come to advisory, or ask me in class. I'll see you. Good luck.